Hello friends, welcome to Civil Mantra. In this video, we discuss about properties of Fourier transforms. In a previous video, also discuss Fourier transforms and cosine and sine rule. In this video, we discuss about properties of Fourier transform. There are 5 important properties: linear property, change of scale property, shifting property, modulation theorem, and conversion theorem. In this video, discuss about 3 properties, and next video discuss 2. Linear property. Firstly, we discuss linear property. Linear property. If f1p and f2p are a Fourier transform of this f1x, this means f1p indicate f1x, right, as and f2p transform indicate this function f2x. The sum of these function and c1 and c2 are the constant function. c1 and c2 are constant. So written as this c1 f1p and c2 f2p equal transform f c1 f1x plus c2 f2x. How can you form this? So see in proof. Suppose that this is transform f c1 f1 x plus c2 f2 x. Okay. Infinitive, minus infinity to infinity, also discussed in a previous video. c1 f1x and c2 f2x, e की power e raised power px dx. This is fx, whole function of fx in transforms. So in a solution, this is constant from c1 minus infinity to infinity f1x and e raised power I की x dx ipx dx plus same as c2 minus infinity to infinity f2, this is x e raised power ipx dx. How can you write? This is f1x. This means c1f. Transform this equation. Also fx equal minus infinity to infinity fx and e raised ipx dx. Also discussed in a previous video. So written as this is function f. This is constant both function. So written as f1x plus c2. When consider this c2 f f2x and this f1 and f2. This is function. So written as c1 f1p indicate f1p is f1x. So f1p plus c2 f2p. This is proof in this result. This is whole term f indicate fx and f2 function of the fx. Those are equal. Now discuss change of scale property. This second property, change of scale property. Same like if fp is the complex Fourier transform of fx, then written as function f Fourier transforms f ax equal 1 upon a p upon a. How? When you see in this proof, when a not equal to 0, when you put this is proof f of f a x. F of x is function, whole function. Infinitive minus infinitive to infinitive e raised I power I p x and f a x dx. When you put ax equal to t, differentiate both sides, dx equal a and dt. When you find dx equal dt upon a, put this function minus infinity to infinity e ax equal t. When you put e I p x t upon a, when you consider x, then t upon a is cancelled out, t upon a, and f, this is t, and include dx equal to dt upon a. When you solve this, 1 upon a is a constant term, and minus infinity to infinity e raised to I p upon a and t, and this is f of t and dt. When you consider this form, then 1 upon a f, this is whole function, is f, this is written as f of indicate f and p upon a. Okay, now let's discuss shifting property. In a shifting property, f of function f x minus a, where e raised I a p f of p, when fp is a complex Fourier transformation of the fx, that means f of p equal f of x. So this is put x minus a equal to t as a u. Okay, and this is constant 0, dx equal to du. Same like put as fx function, f of function Fourier transform f x minus a, where is x, minus infinity to infinity f x minus a e raised I p x and dx. In term of x, we include x minus a. Okay, this is x and x minus a. So minus infinity to infinity, this is term x minus a, x minus is put is u, then f and u. Same e I, x equal to u plus a, I p x equal to u plus a, and du dx equal to du. So also written as this formula minus infinity to infinity f function, and this is u, and expu written as e, this is constant term, e I p u and du. So this term also include minus infinity to infinity f of u and f of u, written as this e I a p. When you apply this integration, the limit, find out final result infinity to infinity e raised I a p f of p. Thank you for watching this video. Friends, like, subscribe and comment. Next video discuss this modulation theorem and convolution theorem.